Welcome to another episode of Machine Learning Made Simple. A lot has happened in the past week in the world of AI and machine learning, and while we cannot possibly cover it all in one episode, we're going to walk you through some of the biggest headlines before diving into the next final part of our RAG series. First up is OpenAI has officially launched GPT 4.5, their newest language model. It's faster, smarter, and more efficient. This model builds on GPT-4's foundation that adds noticeable improvements in reasoning and contextual retention. For early previews, it feels more conversational and aligned with better handling of complex tasks, but it is actually substantially slower than the O1 model. It is positioned to bridge the gap to GPT-5, and set the stage for even more powerful multimodal applications. But when I tested it out, it really was outperformed by ChatGPT O1 model, which is a quite slow model. If you use ChatGPT 4o, O1 is substantially slower because it reasons for a long time. But ChatGPT 4.5 took really long time, and maybe even while I was recording, the ChatGPT 4.5 prompt still has not answered anything. So that being said, it's a slow model, and we'll see how it holds up against the latest generation, the Claude Sonnet 3.7 model, which is substantially better in code generation and every other possible multimodal capabilities, especially the model context protocol that it has introduced, which is taking Claude to the next level, and that's what we're going to talk about next. Claude has silently introduced a major update of their own, the Model Context Protocol, or MCP for short. The protocol is all about making AI assistants smarter by giving them direct access to relevant external tools and data. Think tool calling on steroids, and this is making huge waves that you can connect them directly with your tools and let AI do the work for you. And one of the main videos that's circulating is Claude connecting to Blender, where Blender is used to create 3D scenes and essentially do 3D modeling and animation. So Claude, when connected to Blender 3D, can totally automate the workflow. From a single prompt, it can generate entire scenes and even perform the animation. People are realizing that you don't even have to touch the computer, you don't have to do animation, you don't have to create 3D models. Like you save like hundreds and hundreds of hours of work because Claude can build the 3D models and do the animation for you. Yes, it's not as good as a professional animator, but it's getting there. Operator is an AI agent that can interact with real web pages, typing, clicking, scrolling, and basically operating a browser the same way a human would. This is essentially not new, and this has been there before with this is Claude's computer use, this is Manus AI's automated AI agent that can do all the tasks for you. This is essentially OpenAI's answer to those tools, the computer use and also the Manus AI. So the idea is that rather than giving you the answer, the operator gets the things done. So if you need all the invoices to be extracted from a PDF and put into a spreadsheet, you can give it that command and give it a list of all the PDFs that are open in one of the windows, and also give it access to the spreadsheet. In fact, that's exactly the same thing that Manus AI demonstrated in a recent video. This operator model does exactly the same thing. It will extract the invoice, plug those values into the Google spreadsheet that you have given access to it on the screen. Now, it all, of course, brings up issues with security, privacy, and all those things, but those can be clearly circumvented because you can just spin up a virtual environment or virtual OS, install your Linux, and just run this model in that virtual sandbox environment, and nothing will be taken away in terms of privacy. But the main concern here is the price point. This operator model is only available for ChatGPT Pro users, which costs $200 a month. I mean, who can afford that? It's really expensive when the Claude computer use model is quite cheap, and Skyvern is totally free, so it's not as good as the Claude model or the Manus AI, and Manus AI is not publicly available to everyone. So we don't know the Manus AI price point, but this is not publicly available to everyone, so that's fine. But the Claude computer use is available, and it's cheap, and it is not as expensive as $200 a month. Yes, granted, with $200 a month you also get access to the research agents and unlimited advanced voice. I guess for people who are paying $200 a month, this is a really good value add to what they're paying, because for $200 a month, just getting unlimited advanced voice and access to research tools might not be enough, given the same quality research tools are not available at other platforms at a much lower price point. So that being said, you can just explore if you have the Pro subscription. I don't have the Pro subscription, so I cannot talk about that anymore. Have you ever wished you could change the camera angle in a video after it has been filmed? Like, imagine you recorded your friend dancing, but later you thought that this could have looked way cooler from above or on the side. That's exactly what this new AI system can do. It's called Recam Master, and it lets you reimagine a video as if you had shot it from a completely different camera angle. And this is a tremendous development, not just for video editors and content creators, but also for robotics and reinforcement learning researchers. It is rare that one model bridges both the artistic and technical worlds so cleanly. And today we're going to explore quickly why this is such a big deal and how it could change both the industries. This model can take regular video and simulate complex camera motions like tilting, panning, or even circling around an object, as if you had a drone or a Hollywood rig. And what are the results? Stunning. Picture this: instead of a basic sideways pan across a scene, this Recam Master model could replicate the famous sweeping shot in Titanic. Instead of going sideways, it can pan upwards and around, capturing both Jack and Rose from dramatic new angles. Or imagine a scene from Game of Thrones where Daenerys Targaryen, played by Emilia Clarke, stands on the castle walls at Dragonstone overlooking the stormy sea hundreds of feet below, and you could create an alternate shot from around her, sweeping over her shoulder, rising into the sky. You can add dragons to it. The shot was never filmed, but Recam Master can make it real. And now here's something that borders on science fiction. Imagine that iconic scene from Breaking Bad where Walter White is standing motionless in the desert, facing his adversaries. Traditionally, you get only one camera angle, but if the camera could move around him, a full 180-degree arc circling slowly as if we're mounted on a drone or a robotic arm, that kind of immersive cinematic effect usually requires specialized rigs and multiple cameras, but Recam Master can recreate it from just a single video. That is part of what is known as a 4D replication shot for 4D reconstruction. And let's break it down quickly. 3D reconstruction means recreating the shape and structure of an object or a scene, like scanning a statue to generate a 3D model. Think Gaussian splatting. When you add time as the fourth dimension, you're now also reconstructing how the scene is evolving over time. You capture the movement, changes in lighting, and shifting perspective as well, and that is 4D. Recam Master, while not explicitly building the full 3D geometry, is achieving something very close. It is able to simulate what scene would look like from entirely new viewpoints across time using only a two-dimensional video as input. That means it's effectively faking a four-dimensional reconstruction using latent video generation and camera-aware conditioning. And this is huge because traditional four-dimensional construction from a single video is notoriously hard. Most older methods fail when you only have one single viewpoint. You need multiple synchronized cameras to estimate the depth, the motion, and consistency. But Recam Master has learned how scenes should behave from all this synthetic data or training it has done, and uses the knowledge to generate the plausible new views. So what you're seeing isn't just a visual trick, it's a shortcut to virtual cinematography built on generative AI rather than real cameras. And this opens the door for cinematic creativity at a whole new level. Movie editors, content creators, and even YouTubers are going to fall head over heels for this technology. You could make alternate cuts of films, generate creative trailers, or give your vlog an epic feel without ever touching a second camera. But beyond the world of movies, the most promising applications I've seen are in video stabilization and robotics training, and that's what we're going to talk about quickly. Think of all the shaky phone videos you have taken. Recam Master can simulate what the video would have looked like if the camera had been steady. It can smooth out all the jerky motions by reconstructing a stable camera path across time. No gimbals, no post-processing required at all. And I think this will be immediately incorporated in one of those social media sites like Instagram or TikTok or TikTok-like social media sites where people post videos, and sometimes those videos are extremely jerky. People are taking videos while they're in the car. So it can probably real-time process eventually those videos before posting. So you'll see more and more videos posted which are more professional quality. And if you see someone who has been posting jerky videos suddenly switch to professional grade videos, you know what tool they're using. Now, beyond filmmaking, one of the most exciting applications that I think for this Recam Master model is in robotics and reinforcement learning. Take a common example: training a robot to fold laundry or flip an egg. Traditionally, these kinds of learning takes millions of attempts. The robot needs to perform the task over and over again with minor changes in its action and gradually learning from trial and error about what works and what actions don't. It is a slow, expensive, and painfully inefficient process, and there are many advances in reinforcement learning and optimization techniques like PPO or TRPO, and you probably heard about those. These methods help the robots learn faster, but it's because instead of exploring blindly in that infinite parameter space, they cut down on the number of actions the robot needs to explore. They guide the robot to focus on actions that are more likely to work based on their past experience. But even with these smarter strategies, there is still a major bottleneck. You still need to generate that massive amount of data. The more complex the task, the more variety in the environment, and the more training examples that we need to generate to cover all those edge cases. And you can imagine it will take years to train a robot to do even a simple task. And in order to get around this problem, companies like Google scale things up dramatically. So instead of training a single robot and make it do the task millions of times, they deployed hundreds or even thousands of robots to do the task in parallel. And that cuts down on the wall clock time, but it still requires the huge infrastructure, custom robotics labs, and billions of dollars in investment in generating that data set. And that's simply not realistic for researchers or even startups. Now imagine you're one of those solo researchers or a scrappy startup founder without access to the Google scale robotics lab. What if instead of running those physical trials for weeks, you could generate that training data synthetically? And many people are already doing it. There are some NVIDIA setups which lets you do that. But this is a completely different territory. With Recam Master, you can simulate hundreds, if not thousands of variations of the same motion, different camera angles, lighting conditions, speeds, object positions, and more. And you can do this with just a few original recordings, no robotics lab required. Say your robot arm moves to grab a cup to make tea, for example. There are infinite possible trajectories, slightly higher, slightly faster, more to the left, less curved, and so on. Normally, the robot would need physically to try out all those possible trajectories to see which one works. But Recam Master, you can simulate all those variations virtually and enrich your dataset and augment your dataset without ever moving the robot. In fact, this is one of the things that they also did. If you look at the research paper, which I'll discuss in the technical segment, they actually didn't have the dataset. So they augmented the dataset by using the Unreal Engine to take videos or generate videos from multiple different camera angles. And that's why they were able to create such highly enriched massive dataset. And that's essentially the same thing. You create this model which on enriched dataset, and then you create more dataset based on this model which can be applied to diverse tasks, and this is amazing. The same principle applies to autonomous driving. One of the biggest challenges in that space is collecting enough high quality footage of rare or bad events like near misses, unusual weather, or unpredictable pedestrian behavior. Recam Master can help simulate those edge cases, generating new camera angles or movement scenarios that did not exist in the original footage. But it doesn't stop there. At the end of their project page, and I'll post a link, and you can go to their project and you can see the side-by-side comparison with this model with the other camera control models. The results are dramatic. Other models really, if you look at it, you'll see they distort faces, smear motion, lose consistency across frames, fat people become thin, and all kinds of stuff. Recam Master is the only model right now in the market that is as good as a Stable Diffusion model. It is consistent across frames. So if a person is moving to the left, it will keep moving to the left. If the camera is panning to the right, it will keep panning to the right. It stays stable, and no garbled faces that we usually see in the early versions of the Stable Diffusion model, because sometimes face and hands get fused together. Those things are completely eliminated. So this is really a state-of-the-art model. We are now entering a fundamental shift in entertainment industry, one where entire creative workflow is being reimagined, from pre-visualization to cinematography to post-production. Tools like this are set to transform how stories are crafted, filmed, and experienced and retooled. It's fast, it's generalizable, it's powerful. This model doesn't just advance the field, it is redefining this creative process itself. Soon the tools will be abstracted away by multiple layers, but what we really are looking at is a fundamental shift in how creatives are going to engage with their content, and this opens the door to entirely new forms of storytelling. If you're interested, drop in a comment and we can discuss this more. Retrieval Augmented Generation, or RAG. This has been a game changer in AI. It bridges the gap between the language models and the real world knowledge that the language models don't have, the specialized knowledge that it requires, whether it's in legalese or specialized homework assignments. It needs to have access to the external data before it can generate something. While that basic idea is really powerful, RAG or naive RAG has failed people and most enterprises have given up on it. However, the reason is that the naive RAG by itself does tend to bring in irrelevant documents and tend to overwhelm the generation process. So, and there are many more variations on top of naive RAG, and we talked about that in the previous episode, the contriver method and other dense retrieval methods that aim to improve the naive RAG, but it got some success because they got around that, getting those irrelevant documents and getting some semblance of maturity in the retrieval process. Today we are diving into more advanced RAG techniques and how they work, and each of these RAG techniques have their own use cases and own strengths and weaknesses. For example, the graph-based RAGs are very good for research, while the agentic RAG, they have their own specialized use cases. So the agentic RAG, the beauty of the agentic RAG is that AI agents can refine retrieval in real time. So real-time applications do need to use the agentic RAG because graph RAG would be very time-consuming and resource-consuming. So each different advanced RAG method have their own strengths and weaknesses, and that's what we're going to explore today. Today we're going to break down 5 different advanced RAG techniques. We'll go through each of them, how they work, what are their strengths, what are the weaknesses, and what are their specific use cases, because some of them are not very good for certain use cases and some of them are very ideal for certain use cases. Like we just talked about, the agentic system is very good for real-time retrieval systems, while the graph-based system will not be great for the real-time retrieval because they're resource intensive. By the end of this episode, you will not only understand how these different approaches work, but also where they fit into the broader AI landscape. So if you're thinking about implementing the RAG techniques, this is the right episode for you. Let's get started. When we think about retrieval augmented generation, we often imagine AI systems pulling in text chunks from a database and then feeding them into the model, the large language model. But that approach treats documents as isolated pieces of information, which isn't how knowledge really works in the real world. The graph-based RAG system changes that structuring of the information into a web of interconnected entities. And if you're familiar with graph-based systems, essentially creates a network of interconnected entities. For example, cat would be related to mouse and cat would be related to big cats like tiger, but cat will not be very closely related to dolphins. So if you draw a graph, then you'll see the closest neighbors for cats would be mouse, tigers, lions, but dolphins would not be their neighbors. They're far away. They're still under the mammalian network, but they are not close to the cat network. So that's how the graph usually works. You create similar neighboring entities and you group them together by their common properties. The more common properties they have in common, the closer and tighter the network would be, just like a human network. So what are the main use cases of this? Imagine a legal AI analyzing past court cases. So instead of just retrieving paragraphs based on keyword matches, the graph-based RAG will link concepts like precedents, laws, past rulings, and that ensures the AI doesn't just retrieve a random case, but one that is contextually relevant to the argument that is being built by the legal team. So that means contract dispute would pull in similar disputes, similar case outcomes, and applicable legal clauses, all interconnected to each other and then appearing as disjointed pieces. And this has huge implications in especially the legal profession. A great real-world example of this is also in scientific research. A medical AI searching for cancer treatment insights might not just retrieve research papers that mention cancer, but also map out different drugs, how they interact, what clinical trials that has been conducted in the space of cancer research, and how those findings they support each other, and it will create that interconnected mesh of connection between those different drugs and different trials, which trials use which drugs, and essentially to pull. So it's like pulling a web and you get everything close to it. So, and that's one of the examples. So if you pull all the relevant documents for cancer, you're not going to get the research that mentions cancer but not really related to cancer. Maybe it talks about cancer briefly while talking about diet in the context of the diet. So that would be put in a different network of dietary intervention, but you are probably only interested in cancer research. So your search, your graph-based search will only pull that network of documents which are closely tight knit together in the cancer research network and not in the dietary invention network. But this approach comes with a big challenge. It needs structured data, and it's very costly and time consuming to create structured data. If the information isn't already well organized into entities and relationship, the graph approach doesn't work really well. For example, in fast moving domains like breaking news or newly published research, the AI may struggle because it lacks that structured representation of those latest developments, and it takes sometimes a human being and sometimes an automated system to create those graph knowledge-based systems and enter all that data into structured format. And this is where the context-aware RAG steps in and dynamically refines what it retrieves based on the evolving information. And that's what we're going to talk about next. One of the biggest weaknesses of the traditional RAG method is that it treats all retriever equally. It grabs irrelevant documents and floods the system and forces the user to shift through all that unnecessary content, and it also creates hallucination. The context-aware RAG solves this by dynamically refining what it retrieves based on how the conversation or task is developing. A real-world example is Anthropic's Claude models, which has significantly improved the contextual retrieval process, especially in the code generation. So instead of fetching all the relevant documentation at once, it really fetches the information dynamically based on the problem that is being solved. If a developer is debugging a Python function, Claude first retrieves the standard library references that is related to that error. As the user refines the request, perhaps shifting to performance optimization, the Claude will adjust the retrieval process and then pull the relevant best practices. So you see, at each point, it is continuously changing and modifying its retrieval process based on the need of the user, and the profiling techniques it's used is based on the documentation that's required and filters out the irrelevant documents. And this approach improves the accuracy and efficiency by reducing those irrelevant retrievals and improves the code generation. So the way it works is that, first of all, it breaks the documentation into chunks, and with each chunk it applies the context and then passes on to the large language model, and the language model realizes that, okay, the context and the chunk, they don't match. So for the irrelevant documentation, if let's say the Python programmer is debugging, let's say, a function using Fast API, and the context is Fast API, then one of the documentation might not be related to Fast API, it might be related to Django. So then the large language model sees that the context is Fast API, but I got a documentation for Django. I'm going to discard this documentation because it doesn't match the context. So the large language model is made aware of the context based on this retrieval process. But while the context awareness improves the precision, it still relies on a single retrieval strategy at a time. For example, let's say legal AI, it's good, it helps with contextual retrieval, but it also needs the past case law, not just the recent regulatory updates. And that's where the modular RAG comes in. It blends all the different retrieval strategies and tries to deliver the best of all worlds. And that's what we're going to talk about next. No single retrieval method works perfectly in all cases. Some queries are best handled with the traditional keyword-based search, while others require semantic understanding, and some demand structured knowledge retrieval like GraphRag. Modular RAG solves this by using multiple retrieval methods in parallel and combining their outputs dynamically. A great example is an enterprise AI assistant who is managing internal documents. If an employee asks, how do I file a travel expense report? The system can use the BM25-based keyword-based search retrieval to pull in the company policies, and then use a dense retrieval to understand the context, and then use graph retrieval to surface the related reimbursement guidelines between disparate sources of information, all in a single response. The AI isn't just locked into one method, it is adapting based on the query type. This flexibility makes the modular RAG ideal for AI assistant that deal with diverse information sources. And also this will also work especially in the sales pipeline, and we all know in marketing, sales has so many different diverse pipelines that it's almost impossible to collect all of them together. There's always in CSV format, and then some of them are in a CRM, and to collect and manage all of them needs this kind of multimodal AI systems that can perform that modular RAG retrieval process on the text, images, structured data, unstructured data, everything together. However, tuning these multiple retrieval methods is very tricky. If it's not optimized correctly, the modular RAG can pull in redundant and or conflicting information, and then it will totally lose the track. And even when it works well, there is still some major inefficiency. It retrieves everything from scratch every time. It doesn't have a memory, and that's why the memory augmented RAG is crucial, and that's what we're going to talk about next. One of the biggest inefficiencies in RAG is that every request is treated like a fresh request. Even if a user has asked the same question before, the system retrieves all the data again. Memory augmented RAG solves this by remembering past retrievals and responses, making future interactions more efficient and contextually aware. Think of a legal AI handling a long case. If a lawyer has already asked about a specific contract clause, the AI doesn't need to retrieve the same legal documents. It can leverage the previous responses, which saves both time and the computational resources. And this makes the system feel much more resilient and quick. And this is also critical in medical AI. A doctor who is discussing a patient's case with an AI assistant might reference past conversation about similar conditions. Instead of re-explaining everything, the system can recall the previous insights, and which allows smoother and more informed interactions. And that is allowed by this memory augmented RAG. Has to save everything in memory, but it is not too complicated. It has a short-term memory, it has a long-term memory. This method also has a downside. The memory can be a double-edged sword. If not managed carefully, the AI might prioritize outdated information over fresh retrievals. And think about version 1 and version 2. Let's say you have some documents which has changed version, and there is substantially change between the versions. If the old version remains in the memory and AI refuses to fetch the new version, just in terms of efficiency protocols, then it will lead to incorrect answers. And while memory helps retain the context, it really doesn't make retrieval more adaptive. It still follows some predefined steps. So we do need memory. So these RAG methods do need to be augmented with memory, but we cannot stop there. And that's where the agentic RAG comes in and gives the AI the autonomy to refine the retrieval dynamically. Traditional RAG systems follow a rigid retrieval process. You have an input query, you fetch the data, you generate responses, but real-world problems are often messy. It requires adaptability. Agentic RAG introduces autonomous AI agents that can evaluate the query responses and adjust the retrieval process dynamically. Essentially, you take the agentic process and attach the RAG process to it, and this is a very new technique. It's probably a few months old, and we need a complete segment to describe it in more detail. Watch out for the technical segment, which we'll post as a separate segment where we discuss and go more in depth into the agentic RAG techniques. Just coming back to the simplest overview of what agentic RAG is, imagine a research AI that doesn't just fetch information but actively refines the search process. If an initial retrieval pulls in vague or irrelevant results, whatever the reason, the user prompt was not sufficient, it was not detailed enough, or it just had too many hits, let's say it has 1 million hits, then it will get a lot of irrelevant results. So AI doesn't stop there. It will iterate, it will rephrase the original query and filter out all the noise and focus on the most useful resources. Essentially, think of it as like a fine-tuned retriever, which we have explored in the previous episode. We talked about this. There are some contriver-based method or read, retrieve, rewrite, where there is a fine-tuned element which just perform this function. Here, instead of explicitly fine-tuning the large language model, we are using AI agents which can fine-tune on the fly. And this is very useful for exploratory research where a single query may not be enough to find the best information. Essentially, the AI agent can perform both the query augmentation and query refinement at the same time. A practical example is an AI-powered investment assistant who is analyzing financial reports. Instead of retrieving static documents, the system continuously refines its analysis based on the new market data as it evolves, new trends, and the new company performance updates as it comes in. So over time, the system adapts in a pure agentic fashion. However, the biggest trade-off here is the cost. Iterative retrieval is very computationally expensive and requires significant processing power. Plus, without proper constraint, agentic AI and agentic RAG can get stuck in loops, and that's why you have an orchestrator which can break ties and break loops. You do need to do the orchestration very carefully, and it needs to be done by an expert. And that brings us full circle. While each of these RAG techniques enhances retrieval in its own way, the key takeaway is that no single approach is a silver bullet. The best AI systems combine multiple strategies. It balances precision, adaptability, resilience, speed, efficiency, and all those things. So whether you're building an AI-powered assistant, a research tool, or an enterprise knowledge system, the real power lies in understanding each of these individual techniques and using them judiciously where they make the most impact and sense. So that's about it for today. Thanks for listening. Talk to you next week. That's a wrap for today's episode of Machine Learning Made Simple. If you have questions or want to explore AI topics further, please don't hesitate to leave a comment. Until next time, keep exploring and enjoy your AI adventure.